Let's look at percentiles. We have 3 daughters. I measure their heights on a regular basis. A couple of days ago, I measured our 12-year-old daughter and found that she was 5 feet 3 inches tall. Is this unusually tall for a 12-year-old girl? Let's look at the national height chart for girls. This is a reliable source of information. It's from the CDC, Centers for Disease Control and Prevention. Okay, these numbers are a little small. If we turn it sideways, we can get bigger numbers. But to be honest with you, it's kind of weird to turn my head sideways, so I think we'll look back at what we saw a moment ago. This tells you the percentile that a girl falls into based on her height. So in this case, for example, our daughter is 12 years, 3.5 months old. So here's 12 years, 3.5 months. I'd say it's about here. Whoops, sorry. 12 years, 3.5 months. So 12 years, 3.5 months. A little wildly, sorry about that. And she's a little over 63 inches tall. Okay, so notice that would put her between the 75th percentile and the 90th percentile. This curve is the 75th. This curve is the 90th. That might be a little too wildly for you. So another way to do this is to go to a website which shows you the height for age percentiles for girls. You enter her age, 12 years, 3.5 months is 12.37 years. And the height, well, 63.2 inches. She's a little over 63 inches tall. And we're told that the percentile is 82.9. In other words, the 83rd percentile. So again, our daughter's 12 years, 3.5 months old. She's 5 feet 3 inches tall. This puts her at the 83rd percentile for height. What does that mean? If she's at the 83rd percentile, that means that 83% of girls her age are shorter than she is. Now suppose a woman's 20 years old. What height corresponds to the 50th percentile? Again, let's look at this chart. 20 years old. So we're looking at, this line over here. And if you're at the 50th percentile, that means you're a little bit above 64 inches tall. You can, oh man, it's a little bit easier if you see this. So again, here's that line, 20 years old, and the 50th percentile, a little over 64 inches tall. It turns out 64.3 inches. Now, the 50th percentile is so common, we have a name for it. If 50% of women are shorter than you, then 50% of women are taller than you. In other words, half the women are shorter, half the women are taller than you. What term do we use for this height? Here's a hint. Half the values are greater, half the values are smaller. This value is right in the middle when the scores are put in order. Does that jog your memory? Do you know what we're talking about? It's called the median. Half the scores are larger, half the scores are smaller. It's the median. Suppose a man's 20 years old. What height corresponds to the 25th percentile? Again, let's look at the national height chart for boys. So 25th percentile, let's blow this up a little bit. So if you're a 20-year-old guy, here's the 20-year-old line. If you're at the 25th percentile, that means you're a tad under 68 inches tall. In essence, 67.7 inches tall. So the 25th percentile is so common that we have a name for it. If 25% of men are shorter than you, then a quarter of men are shorter than you. What term do we use for this height? It's called the first quartile, sometimes represented by Q1, because 1/4 of men are shorter than you. The 75th percentile is the third quartile, sometimes represented by Q3. 3/4 of men are shorter than you. And sometimes we represent the 50th percentile, the median, by Q2. In other words, the second quartile. How do you find the first quartile, Q1? Well, you look at all the values below the median and take the median of those values. How do you find the third quartile? Look at the values above the median and take the median of those values. Let me show you an example. Here are the ages when they won of the 87 winners of the Academy Award for Best Actress since it was first awarded in 1929. This, in other words, is the Oscar for Best Actress. Well, we're going to find the minimum, the first quartile, the median, the third quartile, and the maximum. This is sometimes called a 5-number summary. First, let's order them. 21, 22, 22, blah, 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 all the way up to 80. Now, the minimum is easy. The minimum is just going to be 80. We can figure that one out. Maximum's not too bad to figure out. The minimum was Marley Matlin, In Children of the Lesser God, she's the only deaf actress to win an Academy Award for Best Actress. She played a deaf actress, or she played a deaf person, and she herself is deaf. 80, do you remember which 80-year-old won an Academy Award for Best Actress? That was Jessica Tandy in Finding Miss Daisy, or Driving Miss Daisy, sorry. Okay, so we've got the minimum and the maximum. The median, you remember how to find the median. That's the middle value. So in this case, you have 87 values. That's an odd number, so there will be a middle value. So this would be the median. Now the first quartile, well, you need to find the median of these. So everything that's less than that value, so you need to find all these. So look at all these values from 21 all the way to this 33. And if you look at the median of those values, it turns out there are two values in the middle. There's a 28 and a 29, so we take the average of those, we end up with 28.5. To find the third quartile, we look at all the values that are greater than that 33. So this would range from this 33 to this 80. And when you look at the median of those, you've got two in the middle, so we take the average of 41 and 41, and we get 41. So that's the third quartile. Let's graph these using what's called a box plot. Here's what a box plot looks like. Again, we've got the minimum 21, the first quartile 28.5, the median 33, the third quartile is 41, and the maximum is 80. So here's what a box plot looks like. You've got a number line 20 to 80, and for a box plot, we're just gonna, let's see, the first quartile is at 28.5, so we'll put that here. We're just gonna do this in the old school way. So 28.5, let's make that a little better, 8. And then the other median, let's see, the third quartile is at 41. So let's just label this at 41 here. So this again is Q1. This is Q3. We've got the median, it's about 33. That's going to be about over here. We'll just make that a little dotted line. The median is 33, so that's Q3. And we're going to make a box. So that box shows us the first quartile, the median, and the third quartile. And then we also show the max and the min. The max is 80, so we'll extend this out to 80. And the min is at 21, so we'll extend this out to 21. Those things look like whiskers, so sometimes we call a box plot a box and whisker plot. And this is just one way of illustrating the minimum, the first quartile, the median, the third quartile, and the maximum. Suppose a man is 20 years old. What height corresponds to the 90th percentile? The 10th percentile is called the first decile, D1. The 20th percentile is called the second decile, D2. So the 90th percentile would be the 9th decile, D9. Or, frankly, you can just call it the 90th percentile. Okay, let's look at this. So again, 90th percentile. Let's blow it up a little bit. You're 20 years old. So you're at the 90th percentile. That means you're a little bit over 73 inches tall. In fact, it turns out you'd be 73.2 inches tall. That's the height that corresponds to the 90th percentile. If you are 73.2 inches tall, 90% of 20-year-olds, well, yeah, 90% of 20-year-old men would be shorter than you.